Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O-Levels Physics 5054. Today we have set our hearts to solve a paper 2 of this subject. The paper we have selected for the solution is May-June 2025 2-1 paper. This paper 2 belongs from the Zone 1. The code of this paper is 5054/21/May-June/25. The important thing is that the paper and the marking scheme, which I am using in this video, they are the property of the Cambridge. I have just downloaded this paper and the marking scheme from their website, and I am presenting you the solution of this paper to the best of my knowledge and my abilities and my capabilities. So I hope that this video will be very helpful to you. So let's start today's paper. This is Cambridge O-Levels Physics 5054. So let's start today's paper. And this is May-June 2025 2-1 paper. The time allotted for this paper is 1 hour and 45 minutes. The total marks for this paper are 80, and the value of the G in this paper we will take as 9.8 meter per second square. The calculator is allowed in this paper. So the question number 1 is showing up on your screen. He says, figure 1.1 shows a skydiver falling vertically through the air. In the first part of the fall, her speed increases and her acceleration decreases. In the second part of the ball, her speed is constant. On the figure 1.2, sketch the speed time graph for the skydiver. And then he says, on your graph, mark one point where the speed of the skydiver is increasing with an A, and 1 point where the speed of the skydiver is constant with a B. You see, this is a speed time graph. And in the speed time graph, what we do, the gradient of the speed time graph is equal to the acceleration. If the speed is increasing, then and the acceleration is gradually decreasing, so the curve should go upward, but it should bend. Okay, so let me show you. I have drawn this figure. So here we go. So let me show you. You see, this is the shape which you draw. So you see this gradient is gradually decreasing, which means that, but this graph is going upward. So that means the speed is increasing, but its gradient is gradually decreasing, which means that the acceleration is gradually decreasing. Okay, because the gradient of the speed time graph is equal to the acceleration. So that's why the gradient is gradually decreasing. Here, the speed time graph becomes horizontal, which means that the speed is constant. So at this portion, and here I mark it as A, and at this portion, I mark it as B. Okay, so let me show you the marking scheme. The marking scheme of the May-June 2025 2-1 paper is showing up. He says curves upward at start with decreasing gradient labeled A, horizontal line labeled B, 2 marks. I hope you understand this is the diagram which you have to draw. So the question number 1B part, this is a 1 mark part. Explain how the graph shows that the acceleration decreases as the speed increases. You see, in the speed time graph, the gradient of the speed time graph is equal to the acceleration. So because in our graph, the gradient is gradually decreasing, but the graph is going upward, that shows that the speed is increasing, but the acceleration is gradually decreasing. This is, you can write this in your own words. I have also tried to write this answer, but remember, you always can write a better answer, better wording you can do. So here we have the answer which I wrote. So that is, the gradient of the speed time graph represents acceleration of body. Gradient of the curve is decreasing, shows acceleration is decreasing. But the graph is still going upward, which means the speed is increasing. So it's a 1 mark question. Gradient slope decreases or increase in the speed for the same time, less at later times. Okay. So every time the gradient is decreasing, but the graph is going upward, which means that the speed is increasing, but the acceleration is decreasing. Okay, question number 1 is C part, first portion. During the first part of the fall, there is a resultant vertical force acting downwards on the skydiver. One of the vertical forces acting on the skydiver is her weight. State the name of the other vertical force that acts on the skydiver. You see, when you are falling down in air, so what happens? There are two vertical forces acting on you. One is your weight, which is acting downward, and the other force is the air resistance or the drag of the air, which is acting upward, opposite to your motion. You just have to state the name. The name of that force is air resistance. So let me show you. I have written that answer. Okay, so here we go. So the air resistance acts in the upward direction. So we will see. Okay, so question number 1, C part, its second portion, is a 2 marks question. He says that explain why the resultant vertical force eventually becomes 0. You see, the downward force is your the weight of the body, the skydiver's weight, and the upward force is equals to the air resistance. The air resistance of the body depends upon the speed of the fall. As you know, you are falling down, your speed is increasing. When your speed is increasing gradually, the air resistance experienced by that body is gradually increasing. So the downward force, which is weight, that remains same, but gradually as the speed is increasing, the air resistance is increasing. So that's why the resultant force is equal to the weight minus the air resistance, because the weight is same, but the air resistance is gradually increasing. So the resultant force is gradually decreasing. Eventually, what happens? At some point, what happens? That the air resistance, the speed of the body becomes so much that the air resistance experienced by the body, that becomes equal to the weight of the body. So when the air resistance becomes equal to the weight of the body, the resultant force becomes 0, and then the body falls with the constant velocity. We call that velocity terminal velocity, and the acceleration becomes 0. Resultant force becomes 0 when the air resistance becomes equals to the weight of the body. So at the answer which I wrote, you can always write a better answer. As speed of the skydiver increases, the air resistance acting on the skydiver increases. Eventually, the air resistance becomes equals to weight. Resultant force becomes 0. You can always write a better answer. So C part and air resistance drag, and the 2 marks for the second part is air resistance upward force increases with the increased speed. Air resistance upward force equal balances weight. The answer is right. This is the answer which I wrote. You can always rephrase it. Okay, so question number 1 and its D part. He says at one point the vertical force on the skydiver is 400 newtons downwards. At the same time, at the same instant, the wind causes an additional horizontal force of 100 Newton to the right to act on the skydiver. Draw a vector diagram to determine the resultant of the 400 Newton vertical force and the 100 Newton horizontal force. Place an arrow on all of the forces to show their direction. Determine the magnitude size of this resultant force and its direction in the vertical. You see, this is a 3 marks question. We have to tell the magnitude and we have to tell the direction of the force. So I'm going to use the, the parallelogram law to find the resultant of the two vectors. 400 Newton force is acting downward, 100 Newton force is acting to the right horizontally. I will put both these vectors in such a way that the tails are joined together. Then I will suppose that they are the adjacent sides of a parallelogram, and then I will complete that parallelogram. Then where the tails are joined together, I will join that point with the opposite corner of the parallelogram, and that diagonal will give me the resultant force. So this is how we do the addition of the vectors with the help of the, the two vectors. So here you see, I will choose a scale. So I have chosen that the 1 centimeter represents 50 Newton, 2 centimeter will represent 100 Newton, and 400 Newton will be represented with the 8 centimeter. So you can see I have drawn a line of 8 centimeter vertically downward. And at this tail, I have drawn a line of 2 centimeter, which is horizontal and towards the right. Then I suppose that these are two parallel two adjacent sides of the parallelogram. The same side, same length I draw here, and the same this side I draw here. So our parallelogram is completed. Then where the tails are joined, I join it with the opposite corner, and this diagonal gives me the resultant force. With the help of my scale, I measured this diagonal, and it was 8.2 centimeter. Then I used that the 1 centimeter represents 50 Newton, 8.2 centimeter represents how much? 50 multiplied 8.2, that is 410 Newton. So the magnitude of the resultant force will be 410 Newton. Then I have to tell its angle to the vertical. This is the vertical. I will, with the help of the protractor, I will measure this angle. And when I measured it, it is 14 degree. So the direction is 14 degree to the vertical. So this is how you can add two vectors with the help of the parallelogram law. You can also add two vectors with the triangular law. I have not used the triangular law. You can also use this. Okay, so our answers, you can see here, the answers are right. This is how we use the parallelogram law to add two vectors. I hope you understand this. So the question number 1 is completed. Question number 2, A part, state the principle of moments. It's a 2 marks question. The principle of moments, very important. You have to define it here. You have to write the statement of the principle of moments. Principle of moments says that a body in equilibrium about a pivot, the sum of the clockwise moment about the pivot is equals to the sum of the anti-clockwise moments. So you have to write this. I have already written this. Let me show you. And here we go. Question number 2. I have written this statement, and you can check it from the book also. You can write this principle of moment statement from your book. If a body is in equilibrium about a pivot, sum of the clockwise moment is equal to the sum of the anti-clockwise moments. This is the statement of the principle of the moments. Question number 2, A part. And here comes the marking scheme. Okay. So in equilibrium, saying the in equilibrium word is very, very important. You see, when most of my students write this two marks answer, they do not write in equilibrium. The word a body in equilibrium is very, very important. Okay. So then we have the question number 2. It's B part. He says an airline passenger wishes to check the weight of a suitcase that he carries as hand luggage onto an aeroplane. He uses a uniform plank of wood pivoted at its center as shown in the figure 2.1. The plank is balanced with the suitcase on one side of the pivot and 3 bags of sugar, each of mass 2 kg on the other side. The distances are shown on the figure. So 2 kg, 2 kg, 2 kg, total 6 kg. We can find its weight. The distance from the pivot is 80 centimeter. Here is his suitcase. His distance from the pivot is 90 centimeter. So, we have to find the weight of the one. The distances are shown in the figure. Calculate the weight of the 1 bag of the sugar. You see the 1 bag of the sugar is of 2 kg. W is equals to mg. The mass is given. The G value is 9.8 Newton per kg. So simply apply that formula. W is equals to mg. Very famous and very favorite question of the cameras. W is equals to mg. W will be equals to 2 into 9.8 and W will be equals to 19.6 Newton. So 19.6 Newton is the answer, sir. 19.6 Newton is the right answer. This is how this is done. So then they say the maximum weight of a suitcase that can be carried onto the aeroplane is 67 Newton. Determine whether the weight of the suitcase exceeds the maximum allowed. Show a calculation in your answer. So first of all, I will apply the principle of moments on this diagram and I will try to find out what is the. So these suitcases, they are trying to produce anti-clockwise moment. Sorry, these bags of the sugar, they are trying to produce anti-clockwise moment about the pivot. This suitcase is trying to produce the clockwise moment about the pivot. Because they are in equilibrium, so the clockwise moment is equal to the anti-clockwise moment. So I will apply that formula, and here we go. The clockwise moment is equals to the anti-clockwise moment. And so the clockwise moment will be the weight of the suitcase into 90 divided by 100. I converted 90 centimeter, the moment arm, into the centimeters. And 3, because there are 3 sugar bags over each other. So the weight of the one sugar bag is 19.6, multiply 80 divided by 100. 80 is its moment arm, the distance from the pivot. So it will be 52.3. When you do this calculation, so W will be equal to 53 Newton. They said that the allowed limit of the weight is 67 Newton. The weight of his suitcase is 52.3 Newton. So the weight of the suitcase is only 52.3 Newton, which has not exceeded the 67 Newton limit of the weight of that airline. So I hope you understand this. And so our answers are right. You can look at the marking scheme. This is how this is done. I hope you understand this diagram. So now we are on the question number 2, and it's a C part. Here they say that a tall bus is tested for stability. Figure 2.2 shows the bus on a slope. The center of the gravity of the bus is marked. State what is meant by the center of gravity of an object. The center of the gravity of an object. It's a 1-mark question. It's a definition. And you know, the center of gravity of a body is a point in the body or out of the body, where all the weight of the body seems to be acting. If you support the body from there, you will support all the weight of the body. So this is the definition of the center of the gravity. You can always check the center of gravity's definition from your book also. A point in the body where all its weight seems to be acting. The definition of the place where weight of object can be taken to act. Okay. So here we go. The next part is, he says that when the slope is made very steep, the bus falls over by rotating about the point P. Explain why the bus falls over. Okay, so try to understand this thing. And here you see, this is the center of gravity. So the line of action of the weight is here. This is on the right side of the pivot. So it's producing a clockwise moment, so it will not let the bus fall. But if you make the slope more and more steeper, what will happen? The line of action of the weight will become on the left side of the pivot. When it will be on the left side of the pivot, it will produce anti-clockwise moment, and then the bus will fall. Let me explain you further. I have drawn it on the diagram, I think here. No, I have not drawn it. Okay. So try to understand this theoretical answer. Line of action of the weight comes out of the base or on the left side of the point P. This produces anti-clockwise moment about the P. The bus falls over. The anti-clockwise moment will become more than the clockwise moment in that case, and the bus will fall over to the left side. So the center of gravity falls outside the base to the left of the P. Weight causes the anti-clockwise moment turning effect. So the moment will be no more balanced and the body will fall because the line of action of the weight will be on the left side of the point P in that case, when the slope will become very, very steep. The bus will fall to the left. So this was the question number 2, 8 marks total for that question. Now we are on the question number 3. Here we have a battery, a pulley, and a motor are used to lift a load as shown in the figure 3.1. So here you have a battery, it's powering this motor. This is an electric motor. Okay, so it's lifting through this pulley a load in the upward direction. Describe the transfer of energy between the stores that occur as the load is lifted. As you are lifting the load, the battery has the chemical potential energy. The battery has the chemical potential energy that converts into electric energy. And in the motor, that electric energy converts into mechanical energy, and some heat is also produced due to the flow of the charges in the electric motor. And that, so it means that the chemical potential energy converted into electric energy, electric energy will be converted into the mechanical energy, and some of the energy will be wasted in the form of thermal energy because some heat is produced. Then what will happen? The load will be lifted upward. When the load will go upward, its gravitational potential energy will increase. When the load is moving upward, it will have to overcome the air resistance also. So when you overcome the air resistance, some of your energy will be also converted into the heat energy. So it's a 3 marks question. Let's see what I have written. Then we will check the marking scheme as well. The answer which I wrote is um, chemical potential energy of the battery convert the chemical potential energy of the battery convert into mechanical energy of motor. Some energy convert into thermal energy due to flow of current. Mechanical energy of the motor convert into the gravitational potential energy of the load. Uh, it means that the gravitational potential energy of the load increases. It's a 3 marks question. The phrases I use might not be that good, but you can always write a better answer. You can rephrase it by understanding what I'm saying. He says any three from. So from these statements, any 3 statements you have to write. Reduction in the chemical energy stored in the battery, electric work done by motor, mechanical work done on weight, increase in gravitational potential, gravitational energy store of the weight, increase in the thermal energy in the motor or air, electrical heating by current. So you have to write 3 things. You can rephrase it, write a better answer, sir. Question number 3. We are working on the B part of the question number 3. The efficiency of the motor pulley and load system is less than 100%. By comparing the input energy and the useful output energy, explain why the efficiency is less than 100%. You see, whenever you provide input energy, you get some useful output energy and you get some wasted output energy. The wasted output energy is in the form of heat. When you overcome the air resistance, when you overcome the resistance in the cables, the heat is produced, and that heat is dissipated into the air, which is a waste of energy. So the input energy is more and the useful output energy is always less, and the useful output energy is less than the input energy because some of your energy will be converted into thermal energy, will be dissipated into air, which will be a waste of energy. So the answer which I wrote is useful output energy is less than the input energy. This is what I wrote. Useful or output energy is less than the input energy. So this is what I wrote. You can always write a better answer, sir. Explain how the principle of conservation of energy applies in lifting the load. You see, according to the principle of conservation of energy, the total energy of an isolated system always remains constant, but the energy changes from one form to another form. That's the principle of the conservation of energy. You see, the energy which you have, the input energy, that will be converted into the useful output energy plus the thermal energy, which will be dissipated into the air, which will be a wastage of the energy. So the answer which I wrote is the total energy remains constant. The chemical potential energy of the battery is equals to the sum of the increase in the gravitational potential energy, which is the useful energy of the load, and the thermal energy produced. Thermal energy is produced when you overcome the air resistance, and the thermal energy is produced when you overcome the resistance, electric resistance of the wires in the motor. So this is what I have written here. The total energy is constant. Energy from the power supply is equal to the energy gained by the weight plus the thermal energy to air due to the friction. I hope you understand this. And this is my written answer. You can always write a better answer, sir. Question number 3, it's C part. He says the input power to the motor is 15 watt. The motor is used for 20 seconds. The efficiency of the motor is 60%. Calculate the energy supplied to the load. Okay. So the input power we know and the output power we can calculate. The motor is only 60% efficient. Then we can calculate the energy as well. Okay. So you know the efficiency is equals to the useful output power divided by the input power multiplied 100. So the efficiency is 60%. The output power we don't know. That's X. Input power is 15 watts multiplied 100. So the value of the X will be 9 watt. Now I know the output power, the useful output power, and I know the time for which the motor has worked, that is 20 seconds. So just multiply the power and the time, you get the energy. So 9 multiplied 20, that is 180 joules. 180 joules is the answer, sir. Let's check. 180 joules is the right answer, sir. This is how this numerical is done. And we are done with the question number 3. That was a total 8 marks question. I hope you understand. The question number 4. The question number 4. A part. Evaporation of water from the surface of the skin causes cooling. Describe using ideas about the particles. How the evaporation causes cooling is a 2 marks question. You see the water on your skin. The particles of the water which have higher kinetic energy, they will evaporate from the surface of the water, and the leaving behind those water molecules whose kinetic energy is less. So the average kinetic energy of that water will decrease. You know, the temperature of the water depends upon the average kinetic energy of its particles. So the temperature of that water will drop and your skin will feel cold. Your skin will start feeling cold. Okay, so this is my explanation. Let me show you. I have written this answer as well. So here we have the question number 2. Question number 4A, first part's answer. From the skin, molecules of the water with the higher kinetic energy escape into air, leaving the water molecules with less kinetic energy on the skin. And this causes the drop of temperature in that water. So let me show you the marking scheme. So you see it's very, very important. You see, this is the rule of our life, that we always attempt those questions whose marking scheme from the Cambridge we have. If we have a question whose marking scheme we don't have, we do not attempt that question, because that can harm our concepts. So faster particles escape from water on skin, leaving behind slower particles. So this is the marking scheme. This is the answer of the first part, which I have written. And question number 4A, second part, he says, state one difference between evaporation and the boiling. So you see there are a lot of differences. Evaporation always happens on a range of temperatures. The boiling can happen, only happens on a specific temperature. You see, that's the boiling point. That temperature is called the boiling point. During the evaporation, the temperature drops. During the boiling, the temperature remains constant. And during the evaporation, the bubbles are not formed. During the boiling, the bubbles are formed. Okay? The evaporation happens from the surface of the water, and the boiling happens throughout the body of the water. You only have to write one difference. The difference I wrote is during evaporation, temperature changes, while during boiling, temperature remains constant. So let's check. So these are the differences, and you have to write only one of them. So the question number 4 and its B part showing up on your screen, he says, when a refrigerator is switched on, cooling coils placed at the top of the space inside the refrigerator becomes cold. This causes a convection current which cools the air inside the refrigerator. The refrigerator is shown in the figure 4.1. So on the top of your refrigerator, we have those cooling coils, and you see the air near them, that will become cold. The particles of those air particles, that air will come close to each other. The density of that cold air will increase, and that cold air will go downward. From the bottom, the hot air, relatively hot air, which will be relatively less dense, that will rise upward. So the cold, dense air is going downward. The hot and the less dense air is rising upward. This way, the convection currents are created in the refrigerator. Explain how the cooling coils causes a convection current in the air inside the refrigerator. 2 marks question. I just gave you that how this is done. Okay. So here we have the air near the cooling coil becomes cold and dense. This dense air sinks downwards. From bottom, relatively hot and less dense air rises upward. So this is how the convection currents are produced inside the refrigerator. So this is how you can write always a better answer, sir. So the question number 4 and its B part and its second part. Here, the food in the refrigerator is initially at a temperature of 20 degrees centigrade. The food has a mass of 3.6 kg and a specific heat capacity of 3000 joules per kg per degree centigrade. Calculate the final temperature of the food after 160,000 joules of thermal energy is removed from it. Okay, so the mass of that thing is 3.6 kg. The specific heat capacity also has kg. So they are consistent with each other. Heat is equals to mc delta theta. Remember that formula? Heat is equals to mc delta theta. So delta theta, if you want to find out, that will be heat divided by m divided by c. The heat is 160,000. M value is 3.6 kg. The C, specific heat capacity, is 3000 joules per kg per degree centigrade. And so when you do this calculation, the delta theta will be 14.8 degrees centigrade, which means the change in the temperature. So the T2 will be because the temperature is dropping, the initial temperature minus the change in the temperature, 20 degree minus 14.8. So 5.2 degrees centigrade. The final temperature will be 5.2 degrees centigrade here because the temperature was decreasing. That's why to find the final temperature, we have initial temperature minus the change in the temperature. So the final temperature will be 5.2 degrees centigrade. I hope you understand. And that is right answer. This is how we do this. Heat is equal to mc delta theta, where the m is the mass of the body, c is the specific heat capacity of the body, delta theta means the change in the temperature, and heat is already given here. So I hope you understand this. Question number 5 is showing up on your screen. The figure 5.1 is a diagram showing the arrangement of the air particles as a longitudinal wave passes through them. On the figure 5.1, mark the center of the compression with the letter C and mark the center of the rarefaction with the letter R, where the particles are very close to each other, that is the compression, and where the particles are away from each other, air particles, that is rarefaction. So let me show you. So here I can see this is compression, rarefaction, compression, rarefaction, compression, rarefaction, compression. I hope you understand this. This is question number 5. Okay, sir, this is how this is done. The next question number 5A part, its second portion, describe the difference between a compression and a rarefaction. In the compression, the air particles are very close to each other. In a rarefaction, the particles are relatively away from each other. In the compression, the density of the air becomes higher. In the rarefaction, the density of the air is lower. In the compression, the pressure is more than the normal pressure of the air. In the rarefaction, the pressure of those air becomes less than the normal pressure. So you have to only write one difference. I think in compression, density of air is higher than the density of the air in the rarefaction. You just have to write one difference. Okay, so this is what I have written. You can always write a different answer, but by consulting the marking scheme. Okay. Then we have the question number 5, is B part. He says, in a ripple tank, a water wave is produced by a wooden bar moving up and down on the surface of the water. The wooden bar makes 45 complete oscillations in 1 minute. Okay. Calculate the frequency of the waves produced. The frequency is the number of waves per unit time. I know the number of waves. I know the time. Just divide the number of waves with the time, and you will get the frequency. You know the time must be in seconds. 1 minute means 60 seconds. So let me show you. I have done this. Frequency is equals to wave divided by the number of waves divided by the time. And the time is 60 seconds. And so 45 divided by 60, that is 0.75 hertz. 0.75 hertz is the right answer, sir. This is how I have done. I hope you understand. So question number 5B and its second part, he says the frequency of the water wave is increased by moving the wooden bar up and down more quickly. State what happens to the speed and what happens to the wavelength of the wave. But you see the speed of the when the water wave is traveling, the speed of the wave depends upon the depth of the water. If the depth of the water will change, the speed will change. Because here the depth of the water is not changing, the speed will remain constant, so the speed will not change. But the wavelength will change. Why the wavelength will change? You see, because you have increased the frequency. Try to understand this. This is a very technical point. Because you have increased the speed, because you have increased the frequency. When you increase the frequency, the time period of the wave becomes smaller and the speed of the wave is constant. Now the wave is completed in less time, but the speed of the wave is constant. So now in less time, the speed will cover less distance. The wave will cover less distance. Because the time period of the wave has decreased, the speed is constant. Now in the shorter time, the wave will be completed and the wave will cover less distance because the speed is same, but the time has become smaller. When you increase the frequency, the time period decreases, speed is constant. So the time period is smaller, so the wave will cover less distance, so the wavelength will decrease. A very highly technical thing to answer what will happen with the speed and what will happen with the wavelength. And they said, do not explain it. They just said state, but how to state? It's a very technical question. Okay, question number 5, and it's B part, and it's the third portion. Here we have the crust of the water waves moves into the shallow region shown in the figure 5.2. So here the water is deep, here the water is shallow. This is the boundary between the deep and the shallow water. You know, when the water waves enter into the shallow water, their speed decreases, their wavelength decreases, they bend towards normal. The behavior of the water waves, this behavior of the water waves is very, very, very important. When the water waves will enter from deep water into shallow water, their speed will decrease, their wavelength will decrease, they will bend towards normal. Okay, so the question is on the figure 5.2, draw the crust in the shallow region. So question number is a 2 marks question. So what I will do, try to understand this. I will prolong this direction line. When it touches the boundary, at that point, I will draw a normal to the boundary. Then I will bend the direction line in that shallow water towards the normal. And then with the help of the protector, I'm going to draw the wavefronts. Okay. So let me show you. This is, I have taken multiple photos of this thing and to show you how this is done. So you see here, you can see I have drawn that direction line until I touch the boundary of the shallow water and the deep water. I have prolonged this direction line, the direction of the wavefronts, the direction of the wave. Okay. Then what will happen? And here we go. Then I will draw a normal. Okay. At the point where the direction line touched that barrier, or sorry, not the barrier, it's the boundary. Okay, at that point I will draw normal. Normal is making 90-degree angle with that boundary. So this dotted line is basically normal. Okay, then I will draw this direction line in that shallow region. The direction line, the water waves should bend towards the normal, because you see this is the direction line in the shallow water. You can see this is the original track of the wave, but it has bended towards the normal. This is the normal. You can see this dotted line. It has bended towards the normal. Then I will use my protector. I will put my protector in such a way. Let me show you. Okay, so we can make it one step further. Okay, let me show you this. Okay, you see I put my protector in such a way that this crosshair and this 90 mark remains on that direction line. And then I move this my protector closer to this, towards these wavefronts. When I touch this straight edge of this protector, touch this point where the wavefront is touching the boundary, then along this I will draw a line. That is my wavefront in the shallow water. Then I will further move it. When my straight edge will touch this point, and the condition is that you have to keep this crosshair and the 90-degree mark on this direction line. So I will draw this, then this, then this. You can see, can you see this? That automatically the wavefronts which are drawn in the shallow water they have become closer to each other. That means the wavelength of the water waves in the shallow water has decreased. So this is how this is done. So what they have written. This is the answer, sir. I hope you have understood this. And then we have the question number 5, and it's a DC part. It's a 1-mark question. Describe what is meant by the diffraction of a water wave. So it's a definition, 1 mark for this. Okay. So let me show you. I have written this. So when the water waves passes through a gap, they convert into circular waves, and or they bend on the edges. So that is called the diffraction. Diffraction is if the spreading of the waves when they pass through a gap or round the edge of an obstacle. When they go round, round means the verb round, the edge of an obstacle, they bend or they spread, they convert into circular. So that is called the diffraction. You can check your book also to write a better meaning of diffraction. So the marking scheme is showing up in front of you. This is what I have written. You can always write a better answer. So we are done with the question number 5. Question number 6. A student sets up a circuit to determine the resistance of a length of wire. The circuit contains a battery of unknown EMF, a length of wire used to make a resistor X, an ammeter, a voltmeter, and a variable resistance R. Figure 6.1 shows part of the circuit diagram. So their question is, okay, on the figure 6.1, complete the circuit diagram by adding 1 voltmeter and 1 ammeter in suitable places to allow the determination of the resistance of the R. So I will here add an ammeter in series with the X, and parallel to this X, I will add a voltmeter. Very carefully, I have to do this. Let me show you. Okay. So here you can see I have added an ammeter, which will be measuring the current, and the ammeter is always connected in series. The voltmeter I have connected in parallel to the X, and the voltmeter will be measuring the voltage drop. So this is what they are asking you to do. This is the question number 6. So on your screen, the marking scheme is showing for the question number 6. I hope you understand. He says, explain how X and R acts as a variable potential divider. You see, because you have connected X and R in series with each other, so the voltage, which the EMF provided by the battery, some of the voltage drop will happen here, and the rest of the voltage drop will happen here. So now if you take connections from here, you will get a voltage which will be less than the voltage of the battery. So this circuit can be used to divide the voltage. So that's the potential divider. If you remember what is the potential divider, X and R will share the voltage provided by battery. If R increases, the voltage drop across R increases, whereas the voltage drop across X will decrease. So they are sharing the voltage provided by the battery. So the voltage is divided between them depending upon their resistance. So the voltage will be, you can get a less voltage. Any two from X and R share voltage, okay, as R varies, the potential difference across X and R vary. If you will change that variable resistor, the resistance of this variable resistors, the voltage drop across the R and the voltage drop across the X, that will change. So it's a potential divider, basically. Okay, so question number 6, B part. The student determines the resistance of the resistor X for 5 different lengths of the wire, making it the length of the wire range from 20 centimeter to 60 centimeter. The type of wire and the cross-sectional area of the wire are kept constant. Okay, so the only difference between the wires is of their length. And here we have a graph is shown. And that graph, and on the y-axis, the resistance is shown, and on the x-axis, the length is shown in the centimeter. The resistance is shown in the ohm. So what is their question? Their question is state the relationship between the resistance of the wire and the length of the wire. You can, if you look at the shape of this graph, between the resistance and the length, the resistance is the independent variable and the length is the dependent variable. The graph is a straight line with the positive gradient and it is passing through the origin. If you have this kind of the graph, you have studied this in your mathematics, and where the in O levels mathematics you studied that directly proportional, inversely proportional chapter. There you have studied that if the graph between two quantities, the graph passes through the origin and it has a positive gradient, both are directly proportional to each other. Another way of saying this is because when you double the length, the resistance also becomes double. So that means the length, resistance and the length, they are directly proportional to each other. Okay, let me show you. I have written the answer. Resistance of the wire is directly proportional to the length of the wire. You just have to state, you don't have to explain. I was explaining, but you only have to just state what's the meaning, okay? Just state, don't explain. But I was explaining, okay? So you have to, because if you have that concept, then you state, okay? Calculate the current in a 90 centimeter length of the wire when there is a potential difference of 9 volt across it, okay? So from this graph, when the length is 90, this is the length of 90, I have to find. So prolong this graph, okay? And from 90, check what is the resistance. I know the voltage drop, I can calculate the, so first of all, I will prolong that graph, okay? I prolong that graph, okay, 90 is here. So from here, go to this and then check what is the value here. So note it down, that's the resistance of that wire. So from the graph, I know that the resistance of the 90 centimeter length of the wire is 5.4 ohm. The voltage drop they have told us is 9 volt. So according to the Ohm's law, V is equals to IR, I is equals to V divided by R. So 9 divided by 5.4, and that is 1.666 ampere. So that's 1.7 ampere, correct to two significant figures because the data has only two significant figures. So that's why we rounded it off to two significant figures. 1.7 ampere. 1.7 ampere is the right answer, sir. I hope you understand how we used to that graph, the graph, to find the resistance of the 90 centimeter length of the wire. And then by using the Ohm's law, we are able to tell what is the current. Okay. So now we will go to the next part. So that is the question number 6. It's A, it's B, and the third part. The potential difference across the wire making the resistor X is kept constant for all the measurements of resistance. Describe the relationship between the current in the wire and the length of the wire. You know, on the length of the wire, the resistance of the wire depends. Okay, if you will keep the potential difference same, if you will increase the length, the resistance will increase, that will decrease the current. So the relationship between the length of the wire and the current flowing through that wire, if the voltage is kept constant, is inverse relation is between them. So the length wire have higher, longer wires have higher resistance. Higher the resistance of the wire, lesser or smaller is the amount of the current flowing through it. They are inversely proportional to each other. I hope you understand. Now, question number 6 and its C part is state how the resistance of a wire depends upon the cross-sectional area of the wire. The cross-sectional area of the wire and the resistance of the wire, they are inversely proportional to each other. If you will increase the area, the cross-sectional area of the wire, the resistance will decrease. If you will decrease the cross-sectional area, the resistance of the wire will increase. That's why we say the thick wires has less resistance and the thin wires have higher resistance. It's a 1-mark question. You only have to state resistance of wire is inversely proportional to the cross-sectional area of the wire. So we are done with the question number 6. That question was of 10 marks and I hope you understand. So we are going to the next question. That is the question number 7. Figure 7.1 shows an alternating current AC power supply connected to a transformer. Okay, so here we have a transformer. This side is called the primary side. This side is called the secondary side. And this coil is called the primary coil. This coil is called the secondary coil. Here we have an iron core on which you have wound these wires. In the primary coil, you provide yourself the alternating current. And in the secondary coil, automatically alternating current is induced. Alternating EMF is induced. Is question number 7, A part. He says that it's a 3-mark part. Explain how an alternating current in the primary coil produces an alternating voltage. Okay, so 3 marks question. Try to understand this thing. Very important and a very famous question. You see, in the primary coil, you provide the alternating current. You know the alternating current, the direction and the magnitude periodically changes. The alternating current, the direction of the current, and the magnitude of that current periodically changes. Okay. When the current flows through this primary coil becomes electromagnet because the current flowing through it, its magnitude and direction is periodically changing. So the electromagnet which is formed on this primary coil, its polarity and the magnetic strength also gradually changes. So sometimes what happens, this end becomes north and this end is south. And after the half cycle of the current, this lower end becomes the north and the top end becomes the south. The magnetic lines of this electromagnet through this iron core, they pass through this secondary coil. So in the half cycle of this alternating current, for example, if this top is north, they are flowing like this, the magnetic lines. And the other half of that cycle, they flow like this. So the magnetic lines or the magnetic flux, which is passing through the secondary coil, that is periodically changing. Its direction is changing and its magnitude is as well changing. So what happens whenever through the secondary coil or any coil, if the magnetic flux passing through that coil will be changing, the magnetic flux passing through the coil will be changing. EMF will be induced in that coil. So in the secondary coil, the EMF will be induced. Let me show you. Okay. So explain how an alternating current in the primary coil produces an alternating output voltage. So I hope you understand this. The EMF will be induced in that secondary coil. So here comes my answer. Answer which I wrote. Oh, no. So here we have. A alternating current in the primary coil induces magnetic field. This magnetic field periodically changes its polarity and magnitude. The magnetic flux of that primary coil through iron core passes through the secondary coil. This changing magnetic flux induces EMF in secondary coil because the magnetic lines, because the magnetic flux which is passing through the secondary coil is changing. That's why EMF is induced. And because the direction and the magnitude of that magnetic flux is changing, so that is the reason the EMF induced is also alternating. Let's check what the marking scheme says. Magnetic field produced by the current in the primary iron core transmits magnetic field to secondary coil. Magnetic field is changing, reversing, alternating. Induction of the output voltage in the secondary coil. I hope you understand. You can write a better answer. This is the answer which I wrote. You can always write a better answer. Okay, sir. Then they say a student uses a voltmeter set on a 0 to 10 volt range to measure the input and the output voltage. He obtains the values shown in the figure. So you see, if the input voltage, look at the transformer first of all. Let me show you one thing. It's a step-up transformer. Why this is a step-up transformer? Because in the secondary coil, the number of the turns are more than the number of the turns of the coil in the primary coil. It's a step-up transformer. So it will increase the voltage, okay? So what happens if in the primary coil you are providing 1.2, the output voltage is 2.4, which is the double. If you input voltage in the primary coil is 2.3, the output voltage will be 4.6, which is the double. And if you provide input voltage 4.8 volt, the output voltage will be 9.6 volt, which is double. If you provide 6.4 volt, the output voltage, the ammeter has not shown any reading. You see, if you double the 6.4, it is 12.8 volt. The range of the voltmeter is only from the 0 to 10 volt. And the 12.8 volt is out of its range. That's why the voltmeter has not shown its any reading, because you see the 12.8 volt is out of the range of this voltmeter. So that's why no output voltage reading obtained with this voltmeter when the input voltage is 6.4. When the input voltage is 6.4, the output voltage will be 12.8 volt, which will be out of the range of this voltmeter. That's why the voltmeter is showing no reading. Output voltage when the input voltage 6.4 volt is more than 10 volts, so it's out of the range of the voltmeter. I hope you understand. This is the answer, sir. I hope you have understood. Okay. Then he says the number of the turns on the primary coil is 48 volt. Calculate the number of the turns on the secondary coil. You see the number of turns on the primary coil are given. The number of turns on the secondary coil is questioned. It's a very, very famous formula. Vs by Vp equals to Ns by Np. I can take the any pair. You can pick any pair from here. Voltage in the secondary 2.4, voltage in the primary 1. You can take this pair and you can apply that formula. Vp, here you can see Ns by Np is equal to Vs by Vp. Ns is the question. Np, number of turns in the primary, they are 48. I have chosen the pair 4.8 and 9.6. So 9.6 in the voltage in the secondary, and when you have provided 4.8 voltage in the primary. So you can choose any pair from that table. Okay, I've chosen this one. So the NS will be number of turns on the secondary will be 9.6 multiplied 48 divided by 4.8, that's 96. So the number of the turns in the secondary coil are 96. It's a step-up transformer. The number of turns in the secondary are more than the number of the turns in the primary. And this is a very, very important formula. Okay, so then we have the question number 7 is C part. He says the student uses an oscilloscope to display an alternating output voltage from the transformer. The figure 7.2 shows the front of the oscilloscope before it's connected to the transformer. You can see this is the graph, the screen, and this is the time base. Time base is basically the scale of the x-axis. Scale of the x-axis means that on the x-axis, one square represents, or one division represents how much. And the y gain is the scale for the y-axis of this graph. On the y-axis, we have the voltage. And here, it means that it is set on 2 volts per division. So that means one square on the y-axis represents 2 volt. And that means 1 division on the y-axis equals 2 volt. And on the x-axis, 1 division is equals to 50 millisecond. On the x-axis, we have time. On the y-axis, we have voltage. What's their question? When the oscilloscope is connected to the output of the transformer, a trace representing the alternating output voltage is displayed on the screen. On the figure 7.2, draw a trace representing an alternating output voltage on the screen. You just have to represent any alternating. You know, the alternating is from this meter, it goes up, goes down, goes up. So that shape is called the sinusoidal wave. Sinusoidal wave. So you have to draw a sinusoidal wave. Here you can see I have drawn that. Okay. So just draw any alternating current. Okay. So what I did on the 4 squares on the x-axis, I have completed the wave. It's going 2 steps up, 2 steps down, 2 steps up, 2 steps down, 2 steps up. This is alternating current. Okay, you can choose any. You just have to represent here alternating currents. Okay, so this is how you have to do this. You only have to represent alternating current. Okay. So then their question is, describe how to use the trace to measure the maximum value of the output voltage. So what I do, I take this peak and check how many deviations it is above the mean position. How much it is above the mean position. For example, here it is 2 deviations. So multiply it with the y gain. That's the scale for the y-axis. So this is my answer, sir. I was trying to explain to you. The answer is that, okay. So what we will do, count how many divisions or squares the peak of the wave is above the mean position. Multiply those number of squares with the y gain setting. Y gain setting means the scale for the y-axis. This is my answer, sir. Okay, so now we are on the question number 8. He says plutonium-239. Plutonium-94-239 is an isotope that is used as the fuel in some nuclear reactors. A part, question number 8, A part. State the name of the types of particles found in the nucleus of the plutonium-239 and state how many there are of the each type. You see, in the nucleus, we have protons and neutrons. The protons, this number represents the protons, they are 94. And the number of neutrons is from the mass number, subtract the atomic number. So 239 minus 94, whatever you get, that's the number of the neutrons. So there are two things. In the nucleus, there are protons, which are 94. The neutrons are 239 minus 94, and that will be equal to 145 are present in the nucleus of the plutonium-239. So there are 94 protons and 145 neutrons in the nucleus. I hope you understand this. And then we have the question number 8, and it's B part coming up on your screen. He says the figure 8.1 shows the nuclear fission process that occurs within the fuel rods of the nuclear reactor. So here you see we have a neutron which is accelerated and then bombarded on the nucleus of the plutonium. And what happens? That nucleus breaks and 2 daughter nucleus are formed, and with it 3 further neutrons are formed. You see, these neutrons, they can collide, this neutron can collide with another plutonium atom and do the fission process of that. And this neutron can also do that, and this neutron can also do that. So once you start it, and then 3 neutrons will be formed, they will do the fission of the 3 plutonium atoms. And then what will happen from those 3, the fission of those 3 plutonium atoms, you see the 9 neutrons will be formed. And then those 9 neutrons will be able to do the fission of 9 plutonium atoms. And from those 9 atoms fission, you see 27 neutrons will be formed, and this process will become a chain reaction. Their question is explain how the fission process produces a chain reaction. It's a 2 marks question, and the number of lines given 1, 2, 3, 4. There are 4 number of lines given for the answer. I hope you understand what I have just told you, and here is what I have written. When a neutron hits the nucleus of plutonium, fission takes place. 2 smaller daughter nuclei are formed, plus 3 neutrons are formed. Those 3 neutrons do fission of other plutonium nuclei, and this process continues. This is how the chain reaction starts. A neutron is absorbed by a plutonium nucleus. At least one released neutron causes another plutonium nucleus to split. So this is how the chain reaction starts. Okay, then he says explain how the control rods are used to increase and decrease the rate of the chain reaction in the nuclear reactor. You see, with the help of the control rods can absorb the neutrons produced. And by absorbing the number of the neutrons, we can control that reaction. We allow few of the neutrons to do the fission, and this is how you control it. So you see the rods of the plutonium. Between the rods of the plutonium, you bring the control rods, and you expose only that portion of the plutonium which you want to do whose fission you want to do. The rest of the plutonium rods are on both the sides or on all the four sides. You keep the control rods so the neutrons cannot reach those portions, that surface of the plutonium. This is how you control it. I hope you understand what I am saying. Insert the control rods between the plutonium rods. Control rods absorb neutrons. Thus, we can control the fission rate of chain reaction by controlling the surface area exposure of the plutonium to the neutrons. This is my answer. I hope you understand what we have written here. He says control rods absorb neutrons. Insert lower rods between the fuel rods to decrease the reaction, because they will absorb the neutrons and they will not let the neutrons reach the plutonium. So that's how you control it. So अच्छा, कहाँ पे? कोई बात नहीं बेटी, कोई बात नहीं, कोई बात नहीं. Okay, the C part is the plutonium-239 decays by emission of an alpha particle. Let me check, I have done this whole thing. Okay. So now we are on the question number 8, and its C part. He says the plutonium-239 decays by emission of an alpha particle. State two differences between an alpha particle and a beta particle. You see, the alpha particle is nucleus of helium, and the beta particle is an electron. The alpha particle has positive charge. The beta particle has negative charge. The mass of the alpha particle, it has 2 neutrons and 2 protons, so its mass is like 4, and the beta particle's mass is 0. So that's the difference between them. So just remember these things. Okay, difference number 1 is the alpha particle is positive, beta particle is negative. Difference number 2, alpha particle has 2 protons and 2 neutrons. It's like a nucleus of helium, whereas the beta particle is an electron, and it do not have proton, it do not have neutron. So here are some of the differences written between the beta particle and the alpha particles. So this is question number 8, C part. We are done with it. Okay, we are going to the question number 8, and it's the D part. He says alpha particles from the radioactive source are detected in a cloud chamber or with a spark counter. Draw a label diagram of either a cloud chamber or a spark counter. Label the position of the radioactive source with an S. So I have I have taken this photo, and let me show you this. So let me bring this down. Size. So my dear students, this is the basic diagram of a cloud chamber. We can increase its size so you can see. Can I increase the size? Okay. Increase, what will happen? I don't know. Okay. So here we have, this is a transparent box. Okay. And at the bottom, we have put foam, and here we have put dry ice. Dry ice is used to cool it down, to decrease the temperature. Here on the top, I have put some kind of carpet, or you can say some kind of the sheet, which is of the black color to make the background black. Okay. Here on these corners, we have, this is a box, okay? And on these corners, what we have alcohol. You can soak you can take cotton and soak it in the alcohol, and we put the alcohol here. Here we have the source of radioactive sample, okay? And on this side, we have a lamp, so the light passes from here, okay? And on the top, we have a glass through which you can see, and you will make the whole room dark. And what will happen? Due to this dry ice, the temperature here will drop, and the water vapors, their temperature will also drop. You see, this radioactive source will be giving out radiation, and that radiation will cause the ionization of the air particles. And when the air particles will become ionized, these water vapors will be attracted to those ionized air particles, and they will attach themselves with those ionized air particles. And due to this light, those ionized air particles with which the vapors of that alcohol has attached, when the light will pass, they will spark. Those vapors which have condensed, they have attached themselves with the air particles who have ionized, so that they will spark in this light. And you have the whole room, you have switched off all the lights. So when you see from this top, you will see sparks coming. So this is how you detect the presence of the radiation. You see, try to understand this again. This is the box, okay? Here we have that foam, that packing material, the white color packing material or insulator. Then we have dry ice. It's like ice, okay? But its temperature remain cold for a very long time. This is dry ice. Then here we have put something which makes the background, the bottom, the floor black color. Here is the source of the radiation. Here we have put something which is dipped in the alcohol. Okay, so here we have put a light. Okay, so and this is the top through which you can see, and switch off the lights of the room, so everything is pitch dark. Now, when you switch on this light and the radiation is given out, so what happens? That radiation will ionize the air present there. The air which will be ionized here, because the temperature of those vapors due to this dry ice will decrease, so they will attach themselves with those ionized air particles. So what will happen? They will attach themselves, the vapors will attach themselves with the ionized air particles. And when the light will pass through those and they will spark, they will produce this spread out of light when the light beams passes through them. So when you see from the top, you see sparks. Okay, so this is the cloud chamber. Okay, so let me show what the alcohol vapors dance to form liquid droplets around the ionized molecules. And what they say here, they say, what is written here? Let me show you. I don't know how to move it. I don't. A felt ring soaked in alcohol to supply alcohol vapors to the chamber. Here we have the radioactive source produces radiation and causes ionization of the vapors. Dry ice cools the alcohol vapors until it is saturated. Foam support the dry ice. Okay, so I hope you understand this. I hope you understand this. Okay, so it's a 2 marks questions. You just have to provide here the okay. So ionization of the air. So I hope you understand. I have drawn this diagram. One of my students, we were solving this question in my class. We have solved this paper in our class. So one of my students, she has drawn this diagram for me on this paper. And the actual diagram I have shown you. This is the actual diagram. You can draw this diagram, sir. Okay. So I hope you understand this. That was a 2 marks question. Then state what causes the cracks in the cloud chamber, or state what causes the sparks in a spark chamber. You see the air particles, they are ionized, and those alcohol vapors, they join themselves, they condense on those ionized air particles. And when the light passes through them, that seems to be sparking. Okay, air particles are ionized and they get attached with the, I hope you understand, I have explained it. And so let's go to the next question. That was the 11 marks question. Question number 9 on your screen. He says the life cycle of a star begins with a large cloud of dust and gas, which collapses. Five later stages of the life cycle of a very massive star are black hole, protostar, red supergiant, stable star, supernova. Place the okay. So so first of all, the cloud of the place these stages in the table 9.1 in order of which they occur. So it's a 2 marks question. First of all, it's a cloud of dust and gas. Then it becomes a protostar. So the protostar will come here. Then it becomes the stable star. So that will come here. Okay. Then it becomes red supergiant. Okay. And then a supernova happens. And after the supernova, a black hole is formed. So let me show you. I have done this on my paper. And here we have a cloud of the dust and the gas that converts into the protostar, then into the stable star, then into the red supergiant, then and the supernova happens, and then a black hole is formed. Let me show you. Let me show you the marking scheme of the question number 9, sir. So here we have the question number 9, a part, and here we go. Okay, I hope you remember the life cycle, the stages of the life cycle of a massive star. There are 2 types of the life cycles. One is for the small stars like our sun, and the life cycle of massive stars. The B part of the question number 9, the original collapse of the cloud of dust and gas that formed the sun was caused by an inward force. State the name of that inward force. The gravity in the core of that cloud of dust, that is causing the inward force, the gravitational pull, the gravity you can say. So it's a very simple, straightforward answer, sir. Okay. Then we have the question number 9b, second portion. Further collapse is prevented by an outward force. The sun will remain in the stable stage of its life cycle for a few billion years. Describe what causes the outward force. You see, when under the gravity, that cloud and the dust come very close to each other. They come so close to each other that temperature rises. When the temperature rises, the fission of those hydrogen to hydrogen atoms start. Sorry, I said the fission. The fusion. Sorry, I said fission. It's fusion. The hydrogen atoms in when they come very close to each other, the temperature rises. Then what happens? Those hydrogen and hydrogen atoms fuse into each other. The fusion reaction starts, and they make helium. And by that process, enormous amount of temperature is produced, heat is produced, the thermal energy is produced. That provides the outward force. That provides the outward force. Okay, so very high temperature produced due to process of the fusion of hydrogen atoms to make helium, and that is providing the outward force. Okay, light is produced and temperature is produced, heat is produced. Okay, that is providing the outward force. He says one of the first supernovas ever. Let me see, I have done the whole part. Yeah. The question number 9 and its C part, he says one of the first supernovas ever observed is known as SN185. It was formed from the explosion of a star in the Milky Way galaxy. The remnants of the SN185 are at a distance of 8,200 light years from Earth. State what is meant by a light year. Light year is a unit for the distance. And it is the distance the light covers in the vacuum in 1 year. Okay, the distance covered by the light in the vacuum in 1 year is called 1 light year. Distance covered by light in 1 year is called a light year. Okay, then their question is state the time that passed between the explosion that formed the SN185 and the electromagnetic radiation from the explosion reaching the Earth. It's a very tricky question. 1 mark. You know, it's 8,200 light years away. Okay. So its answer is 8,200, but this is how we found it. Let me show you. This is the calculation I just calculated. So how much time has passed? That is the distance divided by time. Distance divided by time. The distance is 8,200 light years. In 1 year, we have 365 days. In 24 hours in a day and 60 seconds. Okay. So this is the time multiplied with the speed. That is the distance in meters. And then I divided with the speed. So this number and this number will be cancelled. So you get this answer again. This is in seconds, and that is equals to 8,200 years. 8,200. Difficult question. Okay, this 1 mark is not easy. He just asks you to state the, but how you state it, it's difficult. We have done this calculation. I hope you understand this calculation. Time is equal to the distance traveled by the light divided by the speed of the light. The distance traveled by the light, 8,200 years, light years. Then I converted that distance into meters and then divided with the speed of the light, I get the time. First I got the time in seconds, then I got the time in years. So how much time it will take? 8,200 years. Only one line is given. You have to do this work in your rough work. It's a very tricky 1 number question. Okay, then we have the third part. A recently observed supernova is SN2014J. The remnants of the SN2014J are 12 million light years from Earth outside the Milky Way. There is no redshift in the electromagnetic radiation from the remnants of the SN185, but a large redshift is seen in the electromagnetic radiation from the remnants of the SN2014J. Explain this difference. You see, if a body, a star, which is producing light, is not moving relative to the Earth or the observer, the light which reaches us, its light when reaches us, it do not show redshift. If the star which is producing light is moving away from us, the observer, it's moving away from the observer, then the light, when its light reaches the Earth, the observer, it shows redshift. So when a light shows redshift, that means that thing is moving away. If the light reaching us shows blue shift, that means the light, that source of the light is coming near the observer. Because he said that the SN185 shows no redshift, that means that it is not moving. It is not moving relative to the Earth, I mean, and relative to the observer. And SN2014J, its light is showing redshift, which means it is moving away from the Earth. It's moving away from the observer. This Doppler effect, I hope your teacher has taught you what's the Doppler effect. SN185 has no redshift. He told us that. That shows that it is not moving relative to Earth. SN2014J has redshift. That shows it's moving away from Earth. That's the marking scheme is showing up. This is what I have written. I hope you understand this concept. Okay, then we have the question number 9 and its D part. It says most of the atoms found in the early universe were hydrogen and helium. The universe now contains atoms of heavier elements. Explain how the heavier elements are formed. Okay, you see what happens that at the start, what happens when the star is stable, the hydrogen and hydrogen atoms are fusing into each other and they are making helium. And this process goes on, the star is in the stable condition. And then what happens, one day comes and the hydrogen atoms are exhausted. So when its hydrogen fuel is exhausted, what happens then? The fusion of the helium with the helium starts. And that produces carbon and nitrogen. and then they fuse into each other and they make further uh, heavier elements. So hydrogen helium is formed. First of all, hydrogen is finished. So then the fusion of the helium with the helium starts, and that produces heavier elements. At the end, you see what happens. The iron is produced, and due to the fusion, the iron is produced. And iron do not then fuse. So that when the iron is formed, and then when the iron is a layer of iron is formed around it there, then the explosion supernova takes place. Okay, so this is fusion of the hydrogen atoms forms helium. Once the hydrogen atoms are all exhausted, fusion of the helium atoms starts. This produces heavier elements. The stage is supernova. So at the end, what happens? Eventually, this starts making iron. Then the fusion of the iron with the iron do not happen. So then the supernova takes place. Supernova is an explosion, and the star spreads out its heavier elements into space. Okay, so let's see. By fusion, supernova explosion of the stars, the fusion mentioned in a star. I hope you understand this. So we have reached the end of this paper. That was the work for that question. So we have reached the end of the paper. There were 9 questions in this paper. We have tried to solve. I have tried to provide you the description and the whole of the thing that how this is done. So if you think that this video is useful, my dear students, if you think that this video is useful, so please share the link of this video with your class fellows, with your teachers, with your cousins who are in O levels, your junior students. You see, I have tried my best to explain you these concepts, okay? And the paper and the marking sketch which we used in this video, they are the property of the Cambridge, and I have only provided you the solution of this paper. Please like this video. Please subscribe my channel. Please share the link of this video on your WhatsApp group, on your Instagram, on your TikTok, on your Snapchat, on your Facebook, wherever it's possible. Please share the link of this video. In your Google Classroom, share the link of this video so that the students who do not have a tutor, the students who do not have time to go somewhere, study face-to-face, they can solve this paper with the help of this video. I hope that this video will be very, very helpful for all of you. Thank you very much for taking your time and watching my video. Your support is very, very important for me. Please keep supporting me. Thank you very much, everyone. Have a good night, sir. God bless you all.